Alright, this question is from the geometry section of the kneecap, and let's see how it goes. The circumference of a basketball is between 29 and 30 inches. Which of the following is the best approximation of the radius of a b-ball? Alright, so somehow the circumference of a basketball is related to the radius of a basketball. A basketball is a three-dimensional object, but it's really related to another famous two-dimensional object, and that of course is just a circle. Alright, the circumference of a circle, you should know, is the distance around the circle, and that somehow is related to the radius of a circle. What's the radius of a circle? The radius of a circle is the distance from the center point out to any point on the circle. I'll make the center point a little bit different color than that. So the radius here is yellow, right? The center point is that grayish point, and the circumference is the blue. So, and somehow they're related. Somehow that distance is related. Really, the distance across the entire circle is related to the circumference. Well, how? If you take that distance, and that distance is called the diameter, right? And you times it by a special number called pi, you're going to get the distance around the entire circle, and that's the circumference. Alright, well, that diameter is two of what we care about here. Alright, that's the radius, right? There's one radius, or one radii, and here's another one. Two of them make up a diameter. So a diameter is 2 r's, 2 radii. So this formula can be rewritten this way. 2r pi is equal to the circumference, or on your formula sheet you'll see 2 pi r. Now we're left with just figuring out what is pi. What you might know is that pi is about 3.14. But I think for this problem we can kind of approximate it a little bit easier and just say it's about 3. Pi is about 3. It's a little bit bigger than 3, so any answer we get, we got to know that we're underestimating it by just a little bit, by that amount, 0.14, right? So it's a little less than 3.14 we're using. Alright, so let's look at our picture. They are telling us that the distance around this basketball, so I'll make that in this color. The distance around this whole ball, right? That's about 29 or 30 inches, right? That's the distance around the whole ball. And they're also saying that the distance from the center of the ball, well, actually they're asking us what is the distance from the center of the ball to any point on the outside. And actually this radius can be drawn anywhere, it doesn't matter. As long as it goes from the center and touches a point on the outside, all these are the same distance, right? These are all a radius, radii, different radii. So they want to know how big is that, how big of a distance is this distance right here. Notice that all the answers that they gave us are possible answers for the radii, right? So what we're just going to do is we're going to take each one of these answers and plug it into our formula that we know. Now remember what I said, that in this formula we're using 2 r's, right? So what we're going to do is we're going to double all these. So 10 inches doubled, alright, 10 inches times 2 is 20, right? 7 inches times 2, that's 14. 5 inches times 2, that's 10. And 3 inches times 2 is 6. Now, since we're using 3 for pi, we're going to times all these numbers by 3. And I'll do that in this color here. Times that by 3, multiply that by 3, multiply that by 3, and multiply that by 3. And then we're going to figure out which one comes closer to the magic numbers we're looking for, 29 or 30. It says it's going to be somewhere in between there, so it's going to be like in here, 29 and a half, something like that. And when we do that, we get, for the first one, 60, second one, 42, for the third one, 30, and the last one, 18. So for the one that we use 5 on, that's the answer.